Okay, grade 11 pre-cal, lesson 41, absolute value equations. So when we're doing absolute value, there's always two cases to consider. One is the expression inside the absolute value is positive or zero, and the expression inside the absolute value is negative. So to solve this, you basically do it twice. What you do first is you take the absolute value equation. So we have the absolute value of x minus 3 equals 7, and just get rid of the absolute value symbols. So we just do x minus 3 equals 7, and then just solve it like you normally would, x equals 10. The second one is to take the whole absolute value, replace the absolute value symbols with brackets, and put a negative in front. And then all we do is distribute the negative, or in this case, we can divide both sides by negative. We do the work, and we end up with x equals negative 4. And if you double check it if you want, right? So the solution is either 10 or negative 4. Now, you can practice this, right? Or go back. 10 minus 3 is 7. Absolute value of 7 is 7. Correct. Plug in negative 4. Negative 4 minus 3 is negative 7, but the absolute value of negative 7 is 7. So you always got to check your answers when you're doing this, because you're going to get solutions that are known as extraneous. Flip the second page. We'll do a little bit more difficult one. So here, there's the absolute value equation at the top. Make one positive. So just get rid of the absolute value and make it positive. Solve for it. Bang, x equals 2. Then replace the absolute values with brackets. Put a negative in front. Distribute the negative. And then solve for everything. You end up with x equals 0. Now, we have two answers, but like I said, you got to double check to see if it works. We can do 0 pretty quick, right? 2 times 0 is 0 minus negative 5. Yep. So the absolute value of negative 5 is 5. Over on this side, 3 times 0 is 0. 5 minus 0 is 5. Yep, 5 equals 5. But let's try the 2. So plug the 2 back in. All right, we plug the 2 wherever the x is, the 2 wherever the x is. So we end up with 4 minus 5, absolute value negative 1, which is 1. 5 minus 6, which is negative 1. 1 equals negative 1? No, that's not true. 1 does not equal negative 1. So that one is known as an extraneous root. So we needed the 2 to be able to do the math, but it is not one of the answers. The only answer in this case is x equals 0. Okay, we'll do another one here. Now, move the 12 first. Let's just move the 12. 12 over to the other side. 9 minus 12, negative 3. Whoa, 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 whoa. Stop, 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 stop. We don't have to do any of the work here, because no matter what happens, when we take the absolute value of this 3x minus 4, when we take the absolute value of that, can we ever end up with a negative? No, not in this case. So this statement could never be true in this case. So we have no solution. So do a bit of work off the top, and you might find out you don't have to do any more work, because you can realize there's no solution. Okay, go to the third page. So what we got is, now we're going to do some quadratic. So we have x squared minus 2x equals 1, absolute value of it. So case 1, get rid of the absolute value bracket, just make it positive. Right here, right, there's the positive. Case 2, put it in brackets, make it negative, and then do all the work. Okay, so here, we turned it into a trinomial, and we realized we can't factor that, so we have to do quadratic formula, and we end up with, down here, here's our formulas when we do all the work, 1 plus or minus the root of 2. Okay, the other side over here, we do the work. This one does factor, because this is a perfect square. We end up with x minus 1 equals 0, so x equals 1. Okay, so the solutions, right, are 1 plus root of 2, and 1 minus root of 2. But you should check the original ones to see if those are the solutions. So does this satisfy the original equation? So let's plug in 1 plus root of 2. So wherever we see an x, we replace it with that. And this is just, right, two binomials. We could FOIL those together. This is just distributive property. So we just do that, and we end up with the 2 root of 2 and the 2 root of 2 cancel each other out. These 2's cancel each other out. We end up with 1, absolute value of 1 equals 1. Is that true? Yes, it is. 1 equals 1. Then we do the same thing again, but with 1 minus root of 2. We still end up with the same thing here, 1 equals 1. And you could also check the answer with positive 1. That's a pretty easy one. So in this case, all of them do work. So we have 3 solutions in this case. Okay, let's go to the last page. So we have absolute value of x minus 10 equals x squared minus 10x. Again, do it the same way. Get rid of the absolute values, make one positive. There it is there. Replace the absolute values with brackets and make it negative. Put it there. Go through the math. So this one, we end up with a nice trinomial. It factors. We have 10 and positive 1. This one also factors into a nice trinomial and end up with 10 and negative 1. So are these all solutions? Let's check. Let's do x equal 1. So we plug in x equals 1. You see that absolute value of negative 9 equals, or absolute value of negative 9 equals negative 9. Absolute value of negative 9 is 9 equals negative 9. That's not true, so that's an extraneous root. So that positive 1 was an extraneous root. So we can check with the 10 and we can check with the -1 and we find out those both work. So then our solutions right here, we have x equals -1 and 10. So the math is pretty straightforward. Make one positive, put brackets around it, make it negative, and solve it. But you have to remember, when you get to the final answer, check to see if they are solutions or if they are extraneous roots.